Today we're going to be looking at solving multi-step inequality word problems. The process is going to be very, very similar to solving multi-step equation word problems. We're still going to define our variable. Instead of writing an equation to solve, we're going to write an inequality to solve. And then the biggest difference is on equations. A lot of times, if we define our variables correctly, the answer to the equation is the solution, whereas on inequalities, we're really going to need to make sure that we interpret our solution. So we read the word problem and then we choose what number in the solution set, because remember, inequalities are going to give us a solution set worth of numbers, and we have to figure out which one we're going to use to solve this problem. So let's go ahead and start. It says, Nathan has lost his mother's favorite necklace, so he will rent a metal detector to try to find it. A rental company charges a one-time fee of $15 plus $2 per hour to rent a metal detector. Nathan has only $35 to spend. What's the maximum amount that he can spend to rent the metal detector? Okay, so let's go through this again. There is a one-time fee of $15. Plus $2 per hour, and right there, that per hour is going to help us with our defining it. And we have only $35 to spend. Okay, so we're going to say X equals the number of hours. And then for our equation, our inequality, we are going to say 15 plus that fee of $2 per hour, so 2x. And if I only have $35 to spend, I can spend all of it, so it can equal 35. I cannot spend more of it. I could spend less and have some money left over, so it could be less than or equal to 35. All right, now we're going to go ahead and solve. So first, we're going to subtract the 15. So I've got 2x is less than or equal to 20. Divide by 2. X is less than or equal to 10. And it wants to know the maximum amount. So we are going to say at most 10 hours. If we want to use all of our money, 10 hours. If we can find it in less, then we end up not using all of our money, which would be awesome, but that would be the maximum amount. All right, let's try number 2. Andy, Bobby, and Carl are each 1 year apart in age. So right here, that is my defining the variable. That is like consecutive integers. So we're going to say X is Andy. We are going to say X plus 1 is Bobby. And we're going to say X plus 2 is Carl. And then it says the sum of their ages is greater than, is right there, the symbol we're going to be using, their father who is 60. All right, so let's go ahead and write that. So first we have to add up their ages. So that would be 3x plus 3 needs to be greater than 60. All right, now we're going to go ahead and solve. Subtract 3. 3x is greater than 57. Divide by 3. X is greater than 19. Okay, so if Andy needs to be older than 19, so older than 19, then Bobby needs to be older than 20, which means Carl needs to be older than 22. So what is the youngest age that the oldest brother can be? So older than 22, Carl is older than 22. He is at least 23. So he could be 23 years old or older. We just know he's got to be older than 22. All right, let's try our next one. The area of a triangular garden can be no more than 120 square feet. The base of the triangle is 16. Okay, so what is the height? All right, the base is 16. What is the height? And we've got area no more than 120 feet. Okay, so let's go ahead. First, we're going to draw our picture. That defines our variable on area and perimeter problems. We've got 16, and we've got h. So area, remember, is 1/2 base times height. So area is going to be 8h. No more than means less than or equal to 120. Then from here, we're going to go ahead and solve. Divide by 8. H is less than or equal to 15. And it wants to know the greatest height. So at most 15 feet. Or you could say 15 feet or less. All right, let's go ahead and try our final one. The sum of 4 consecutive odd. All right, right there was my defining variables. I have 4 consecutive odd. So I need to define that part first. X is my first. Remember, odd integers get bigger by 2. So x plus 2 is my second. X plus 4 is my third. And x plus 6 is my fourth. And then it says the sum is at most 100. So let's go ahead and write our equation. 4x plus 12 is at most, means less than or equal to 100. And I want to know what's the maximum value of the smallest integer. Okay, so let's go ahead and solve that. Subtract 12. 4x is less than or equal to 88. Divide by 4. X is less than or equal to 22. Okay, so because it says or equal to, we could use 22. However, we are looking for odd numbers, and 22 is not odd. So that means the biggest odd integer that x could be would be 21. So the smallest integer, which is x, is at most 21. All right, so hopefully that helps you see how similar these problems are in setup to our Unit 2 word problems, yet we do have to be very careful when we go to write our final answer. It does take more interpreting and more thinking. So that is the end of today's multi-step inequality word problems notes.